Hello, everybody. We are the Psychic Coders.
Hi, I'm Bennett.
Hello, I'm Matt Ido, New York.
Hi, I'm Duran Maragira.
Hello, my name is Arlen Chosa.
Hi, I'm Xiaofan Yi.
And this is our Force of a Punch application progress presentation.
So in a dojo, a martial arts instructor will give his students directions on where they need to improve, how they need to change their style, their form, whatever. Most of this information will be based on the instructor's perception, which isn't actual data. And this could lead to the instructor giving wrong advice or inaccurate advice. So to fix this, we decided to create a mobile app that could measure the force of a punch and display those measurements to help instructors offer more valuable advice to their students. The app is built to run on a device attached to a punching bag using a phone mount. It calculates the force of a punch using the sensors within the phone from the built-in accelerometer. The goal of the app is to measure the force, store these values, and track the development of students over a period of time, and also to help instructors provide information on how the students could progress based on these measurements.
So the requirements gathered that need to be met to deliver a successful project is an Android device, which will contain the mobile application, which has the account which tracks the progression of the user's punch, and the accelerometer, which is a sensor built within the Android device, which is used to measure the acceleration of a punching bag. The punching bag is another criteria we need. To be used to punch the bag, and a phone mount, which will be mounted on top of the punching bag and maintains the Android device locked in place. Some technical issues we have here are a wobbly bag, weak base, and the measuring force actually using a phone. So the wobbly bag, the issue here is that the screw underneath the base of the bag sometimes gets loose when overusing the bag, and the pole of the bag tends to wobble. The base itself is weak as we use water to fill our base up, and punching the bag hard enough causes the bag to tip over. The accelerometer on the device will not 100% accurately measure the force of the punch. Therefore, we have to integrate the bag's mass as well as the user's mass to successfully get a reading of the punch.
So to fulfill all the requirements, we came up with a design with two parts. The first part being an Android application that can measure the force of a punch, and it can also track progression, with the second part being having that Android device mounted on top of a punching bag secured by a phone mount.
So here are some pictures of the punching bag itself, the design of it. As you can see, the phone mount, how it's supposed to be positioned on top of the bag. In this case, I've used tape to securely mount the phone on top of the bag, but in the future, this will be super glued on top of the bag. The phone at the bottom here, you can see that how the Android device will be mounted onto the phone mount and how it will look on top of the bag. The base of the bag, as you can see, the bottom left corner is where you can either fill it up with water or fill it up with sand, or so the two pictures on the right shows how the phone will be connected to the bag, and this will be the basic design concept of the punching bag with a phone.
We've also designed a few user interface concepts. These were designed with the intention of demonstrating the features of the application. So far, what we have managed to come up with is an intro screen, shown here on the left, adding a new user, a screen that displays when measuring the force of a punch, and also other screens which aren't shown, but include a user select, a progression screen designed to compare your past results, and a screen to show, to confirm that you have locked your phone into place in the phone mount secured on top of the bag.
So to demonstrate some of the features of our final design, we have created a demo application shown here. So here on the title screen, we can imagine in the future that this will be turned into a user select screen. If we tap to begin, now we can imagine as if we are logged in as a user and are intending to measure our punch. If we punch the bag, the phone will record a maximum acceleration, and we can record this value. If we can punch the bag again and get a new maximum acceleration, 8.4 in this case. We can reset this value and then punch again to get a new value. And we can record more data points. We can also clear all the data so it gets deleted. In the future, this will be akin to a user delete function. And of course, we can record as many data points as we want. So these are some of the features that we have already implemented. In the future, we will flesh out some of the remaining features of the app. First, we will design a more fleshed out user account system, which will incorporate a profile photo, the user's name, height, and weight information. We will also have graphical representation of data. In the demo app, we only recorded the measurements in text form. In the future, we will have a progression graph allowing users to easily see their progression. Also, in the demo version, we only recorded the maximum acceleration. In the final design, we will have a force formula, which will incorporate the maximum acceleration of the phone and the user's weight and height to give the user a more realistic estimate of their punching force.
Testing is an important step in the application development process. We do testing in order to maintain accuracy, consistency, and quality in the final product. Taking into consideration the scope and size of our project, we'll follow a manual testing procedure, and the following 4 tests will be conducted: unit test, integrated test, system test, and user acceptance test. When we do the unit test, we focus on individual codes, and on the integrated testing, this combines all, and it will be done at a higher level. And the system test, it is related to the interface and a database, and the user acceptance test is done to fulfill all the client requirements. And we also prepare the test cases, which are important for checking at different levels of the development process. And we have also to do the performance check, how the application is functioning. And we also try to identify if any lagging program issues occur. And the verification and validation is also an important step in the process. We have to verify to confirm if the application meets the specifications, and we have to be sure and check if there exists any bugs. We have to fix those things. And in the validation, we have to check the performance in comparison with the client requirement.
All right, we also have some frequently asked questions about the project. The first of which being, is this app planned for a single designated device or multiple individual devices? So the app can be used on both. However, the app has been designed specifically with a single device in mind, featuring a user system in which you can create multiple users on a single device, and compare data among users within the single device. However, there is no cross-device comparison feature at the moment, nor is there one planned for in the future.
Another question we've gotten quite often is if we considered using the camera as a way to measure force. And we did consider using it as a way to measure form, not force, but we ultimately decided against it because that will expand the scope of our projects way more than we're ready to accommodate right now.
All right, so if you have any questions or comments about the project or the presentation, you can send any of that over to idone0019 at algonquinlive.com. Thank you for watching our progress presentation.